If you have conducted research on a small corpus of privacy policies, you might have been able to extract the texts of the privacy policies by hand. Also, you might have been able to perform language determination manually, as well as filtering out non-privacy policies from the corpus by hand. But what if you would like to conduct a large-scale study, or you already have a corpus of raw HTML files where you know that it is a mix of privacy policies and non-privacy policies? It might be handy here to have a toolchain which is specialized on detecting privacy policies. Hello, and welcome to the presentation of our paper, Unifying Privacy Policy Detection. I'm Henry, and this is joint work with my supervisor Thomas Hopperich, as well as Martin Degeling and Christine Utz. So, in order to build such a toolchain, which naturally consists of several modules, several steps are necessary. We would have a link detection module, which scrapes potential privacy policies from websites, a text extraction module, which extracts the texts of the privacy policies as completely as possible without any boilerplate. We might need a language determination module based on the scope of your research. If you plan to train classifiers to detect privacy policies, you might have the need to perform manual labeling. Feature engineering, because naturally classifiers need features. The classifier training itself, as well as the validation of the classifier. So in order to build this toolchain, we naturally need data. And luckily, for the English language, there exist already several corpora of privacy policies, as well as a corpus which consists of privacy news incidents. Unfortunately, this is not the case for the German language. Therefore, we created a privacy-related news articles corpus consisting of 112 privacy-related news articles. The reason for creating this corpus and also including the privacy news incidents database in English is to train the classifiers so that they are able to distinguish between privacy policies and privacy-related news articles. And since a similar corpus to the sanitized English corpora of privacy policies does not exist, we need to manually label the GDPR 2019 corpus, which is a multilingual corpus, in order to also obtain labeled data for the German language, as well as to expand the English training set. And for how we accelerated the manual labeling process, as well as detailed statistics on our training set, I refer you to our paper. So we evaluated for text extraction the performance of 7 text from HTML extraction libraries. For this purpose, we created a small corpus of 111 HTML files, which were actually privacy policies. And we manually extracted the policy texts from these HTML files. And as performance metric, we utilized the fuzzy string matching score. So I only show you the best performing libraries with their respective settings. It turns out that the boilerpipe text from HTML extraction library with the numWords rule setting performs best for English and German. The readability.js library performs slightly better for other languages. And the boilerpipe tool with the canola extractor also shows very good results. As a result, we recommend to set boilerpipe with the numWords rule setting as default, and also keep these two text from HTML extraction libraries as backup solutions. Regarding language detection, we decided not to use only a single language detection library, but rather a majority voting scheme which consists of 8 language detection libraries. And 2 of these 8 language detection libraries are able to detect multilingual texts. The reason for building such a scheme is aiming for higher precision regarding language detection. In order to compare this approach with an approach where only a single language detection library was used, we apply our language detection scheme on the Princeton-Leuven longitudinal corpus of privacy policies. And for this corpus, the CLD2 library was used, which is already a very good language detection library. And since we will make use of this corpus as a means to compare our approach with other approaches, we refer to this corpus as the Princeton 2020 from now on. So here you see the results of applying the language detection scheme on the Princeton 2020 corpus. This corpus consists of both privacy policies and non-privacy policies, and is supposed to only contain English texts. As you can see, the CLD2 library already has performed a very good job. However, our language detection scheme is able to catch also multilingual texts, as well as some texts that were in other languages than English. So, as you can see, our scheme increases the language detection precision. So, let's talk about feature engineering and typical text classification leverage n-grams in order to train classifiers. However, due to the diversity of privacy policies, we decided to apply unsupervised key phrase extraction instead and use the key phrases as features in order to train classifiers. The reason behind this is a resulting lower dimensionality in the feature vectors and also having a therefore more resource-saving approach. Let me show you how this looks. So in case that we would have utilized, for example, trigrams as features, we would have something like once you agree to, and agree to allow, so far, and so on. However, key phrase extraction allows to only extract the most important key phrases that exist in the text and discard every other n-grams and phrases that are not considered as the most important key phrases in the text. This is usually performed by either applying statistical measures or by graph theory. Regarding the properties of these selected key phrase extraction algorithms, originally we had 16 candidates. However, we kept only 8 key phrase extraction algorithms in our toolchain, which were applicable on individual texts, were unsupervised so that they do not require any sort of training, domain independent, fast, and also support multiprocessing in order to accelerate the extraction of the key phrases from the texts. And these resulting key phrases for each document form a binary feature vector. So let's talk about the classifier, and we decided to use an ensemble soft voting classifier, which basically consists of 3 underlying classifiers. Each of these classifiers outputs the prediction probability for each of the texts, and the resulting label is determined by choosing the higher mean prediction probability for the text. Each of these classifiers was calibrated so that they output precise prediction probability. And we validated our approach on the resulting training set, and as you can see, we have pretty good results over 99% F1 score as well as 99% balance accuracy. So in order to have a further means of comparison, we applied our classifiers on the Princeton 2020 corpus. And it turns out that for English texts, we have a 96.7 agreement on the labels of the privacy policies. However, we only have a 41.7% agreement on the labels of the non-privacy policies. We manually inspected the assigned labels in order to find out the reason for this observation, and it turns out that our classifier identified privacy policies that had originally been labeled as non-privacy policies. We could observe similar results on the small portion of as German identified texts of this corpus. A detailed analysis on this is also included in the paper. So let's talk about finding potential privacy policies on websites. For this purpose, we implemented 4 methods that had been utilized in previous work. First, a so-called simple English method, which basically searches in the link text for either privacy or the combination of data and protection. Two-step English, which first searches for a smaller list of matches in the link texts, and if no match is found, then it is expanded to a broader list of terms. A multilingual word list has also been implemented as a method in order to search for other privacy policies than English ones. And we also have the context-based approach, which considers both the link text and the previous HTML elements. So we tested these link detection methods on the top 10,000 websites of the Tranquil list at the end of January 2021. And out of 8,624 reachable websites, 7,353 matched at least one of the 4 link detection methods. It turns out that the more extensive the search list actually is, the higher is the number of false positives. For detailed statistics on each of these link detection methods, I refer you to the paper, but what I can demonstrate you here is that if we combine all of these link detection methods, the result, according to our classifier, turns out to only have 57% actual privacy policies for English and 60% for the German language, which indicates that applying only link detection is not enough to have a sanitized corpus of privacy policies. Alright, so we demonstrated that the pre-processing phase for privacy policies is crucial to conduct proper research. And we evaluated candidate tools and carefully selected them to include them in our toolchain. We evaluated several text extraction libraries and included the best one in our toolchain. We demonstrated that majority voting increases the precision of language detection. And we demonstrated that our classifiers help in order to build cleaner corpora of privacy policies. Currently, we only support English and German, but we would be happy to expand our toolchain also to other languages. The source code is available on GitHub. We are looking forward to your contributions. Thank you very much.